Have you ever wondered what light is? What is it made of? Why does it look the way it does? How does it behave? And how can it look different depending on a certain object or the angle from where it hits? These are all questions that have been asked for years and years and centuries, and I've been trying to.
What is light?
What is light? What is light? That's a good question, isn't it? What is light?
Isn't it an element?
Light is brightness, I guess.
We have auras.
We all have auras.
Which are light?
Yes, they are.
It lights up the room. It makes it not dark.
And so, even after years of experimentation, we still don't know what light is. We still wonder, what is light? Many centuries of undergoing investigation and experimentation, both Einstein and Young have come up with peculiar solutions to these questions. Before we get too into investigation and experimentation and everything, do you know what light diffraction is? Or have you ever heard about it? Or about Young's double slit experiment? The debate of light being a particle or a wave started many centuries ago and is still continued today. While Einstein argued that light were mere photons that consisted of particles, Thomas Young said differently in 1801. In his experiments known as the Young double slit, he was observed how light behaved like waves and would interfere in both constructive and destructive manners, such leaving a pattern on a screen that consisted of dots of light mingled with dark spots. Throughout time, it was then concluded that the light spots were created by constructive interference, meaning that when two waves clashed peaks, they ended up adding up, whereas destructive interference occurred when two waves got cancelled out because a negative hat joined up with a positive hat. This interference is usually measured by an intensity plot. It is usual for the highest intensity to be in the middle and then start degrading in a constant pattern towards both sides. Just before the experiment, let me give you a basic definition of what diffraction grating means. A diffraction grating consists of a large number of equally spaced parallel slits, meaning there is more than two slits. However, it can still be done with only two slits. When light is incident on a grating, the light from each slit diffracts and will interfere with the light from the other slit. This causes wave interference, which is based on two different types. What is going on, you're probably wondering. Here I'm going to explain basically what the Young's double slit experiment consisted of. So I have a red laser in hand. Now it is very important to use only a one-colored source of light and to have a white screen taped to a wall so that the product can be seen more easily on the pattern. So what I did was I took my red laser and I shone it through two slits that I created on my own with materials from home. I basically took 4 portaminas of a length of 0.5 and taped them together until they formed very thin slits. Through there I shone the red laser and following my results and all the investigation that went behind this experiment, I had two essential questions that I wanted to answer. Here I leave you with my conclusions. conclusion, through this experiment we can prove that light is not only wave-like, but that when light passes through another lens it will diffract and refract because the waves will clash and interfere, creating a pattern. Moreover, this is usually why, even though we see the sun as white light, when it passes through a prism, or like with the CD, it reflects in multiple colors. Light is not only refracting and changing of angle, but it is also reflecting back. So, many of you may wonder, why is this important? How does knowing that light is a wave will be useful for us? Or what is light diffraction grating useful for? Well, scientists are still researching to prove what light is. However, light diffraction gratings has been used in multiple scenarios on our daily basis. For example, an optical imaging of particular wavelengths from biological or medical samples. A diffraction grating can also be chosen to specifically analyze a wavelength emitted by molecules in deceased cells in a biopsy sample, or to help excite strategetic molecules in a sample with a selected frequency of light. Therefore, in the end, no matter what light is, and light diffraction is something that happens all around us that we don't even notice.